Hello students, welcome to Vinuta's math channel. In this video I am going to discuss about the solutions for the module question paper 1 which is being saved in the Google Drive. The link of the Google Drive where I have saved the model question paper will be provided in the description box. Okay, so here I am solving the problem number 1C. It is from the module 1. The question says simplify the Boolean function f of w x y z which is equal to summation of 0, 1, 2, 4, 6, 7, 9, 12, 14 using the K-map and write the Verilog program for realizing the minimized expression. Okay, so this question has two parts in it. The first part is we have to solve this using the K-map. Okay, so we are having a K-map concept here, and then after solving this expression using a K-map we have to write the Verilog program. Okay, Verilog program for the minimized expression. So let us start with writing a K-map. Fine. For writing a K-map, since it is a 4 variable K-map, I'll write a skeleton of 4 variable K-map. The 4 variable K-map skeleton is ready now. Here the variables are wx and yz. So I'll take the wx here and yz this side. Okay. Next, since it is summation, that is sum of the product form, we need to write the ones in these cell numbers. Okay, to write that, first let me write the values of this or the terms, that is w bar, x bar, and then w bar x, wx, wx bar. In a playlist I have already explained how to write these values here and why we are writing like this. Okay, even the link of that video will be shared in a description box. It might be helpful for you. Okay, so wx variable and here yz variable. So here w bar or a variable bar meaning 0 if we write any variable without a bar meaning 1. Okay, so let us write the cell numbers of these cells. This cell represents the cell number 0, it is 1, then it is 2, and this is 3. This is all being explained in a video called K-map. Okay, you can go through that. Next it is 8, 9, 10, 11, 12, 13, 14, 15. This is a skeleton of the K-map for a 4 variable. Fine. Now let us fill the value 1 for these cell numbers. Okay, see the cell number 0. For this 0 let us write the 1. For 1, 1, and then for 2 it is 1, and then for 4, 6, 7, 9, okay, next 12, next is 14. See, we have written the cell numbers, we have written the 1 in these cell numbers. If the same is being given with pi, okay, meaning product, we have to write zeros. Okay, this is the basic concept. If they have given the don't care, for that don't care we will write the x. Fine. Till here I guess you don't have any doubts. Next, while grouping, while minimizing, we have to do the groups. Okay, to do the groups we have to follow some rules. Okay, to solve any problem we are following 3 rules. Okay, let me tell those 3 rules. For this program or for this problem we can use only 2 rules, so let me tell those 2 rules. Fine. While solving a K-map, first and foremost rule is we have to start either from this side Okay, we should start with this element. Okay, we should start with the 0th element. We can solve row wise, or we can group this one row wise or column wise. Fine. So we have to go row wise. I will use this rule. I'll solve, or I will try to group this one element first, and then this, and then this. Okay, so first I'll try to group this first row, and then second row, third row, and fourth row, so on. Fine. Next, second rule is, while grouping we have to always look for an octet. Okay, you don't know what, if you don't know what is an octet, then go for the K-map videos, which I'll share the link in my description box. You can get to know. Okay, then you can come back to this concept. So first, while grouping, we must always look for making an octet. If octet is not being made, then look for quad. Okay, if quad is also not happening, or not it is not possible to make, then go for pair. If this is also not possible, then leave it single. Okay, so these two rules we will be using while solving this problem. Whenever we get don't care conditions also, in that case I'll tell you the third rule. Fine. So first, what is the rule? We will go row wise. So this is our first row. Since it is our first row, this is the first element. Here we have an element. Okay, so I'm here. Fine. Next, what is the second rule says? We must always look for making an octet. Octet meaning 8 adjacent ones. Try to find, is there any 8 adjacent ones for this one, including this one? See here, 1 2 3. If it was here 1, this 4, and if these two are filled, see here, we would have made this block as an octet, but this is not the case, right? Can I make this and this as an octet? No. Why? Here these cell number 8 and cell number 10 are empty, so I cannot make the octet. Fine. Can you see the other possibilities to make an octet? See here, in this I can make an octet of this and this. Okay, cell numbers, but I don't have ones here in these places, so I'm not able to make an octet. Fine. So what is the next possibility I have to look for? I have to look for an quad. Okay, so for this cell, that is for the cell number 0, let me look for a quad. What is the meaning of quad? We have to look for adjacent 4 ones. Okay, so for this one, is there any adjacent 4 ones? Look for it. Okay, see here, for this one, this is the location where we can get the 4 ones, that is quad. Is there any one here? No, right? So we cannot make a quad in this way. Okay, now one more possibility, this one. Can I make? This is the position, but here we don't have one, so even in this way I cannot make a quad for this one, right? Okay, try to check for other possibilities. If there was one here, I would have made like this, but here also I don't have any one. Check for another cases. If you have any cases where you can make a quad by using this one, wrap around condition. See, roll around. If you roll this K-map, this, in this way we can make a quad, right? Okay, so I'll name this with a number 1. So I made the first group, fine, which is a quad. Fine. Next, I grouped this. Next, what is our rule says? Our rule says we have to go row wise. This I grouped. Then where I have to group? Where I have to go? I have to go for the one where the cell number is 1. Okay, so for this repeat the same thing. Look for an octet. Is there any possibility for this one to become an octet group? Check. Is there any ones in these two lines? No. In these two lines? No. In this and in this line? Yes or no? No, right? So octet possibility, it can't be. We can't do any octet for this one. Correct? Next, for quad, can we make a quad by using this one, cell number 1? Quad, no. If there was a 1 here, we would have make like this, but there is no 1. So can I make? There is no adjacent ones here. There is no adjacent 1 here. So I cannot make a quad. Okay, next, since I am not able to make a quad, I'll go for try to make a pair. I'll try to find a pair for this one which is in cell number 1. Okay, so for this one, try to make a pair. For this one, I can make a pair like this. Fine. And look for other possibilities. Can I make a group that is pair like this, roll around condition? Can I make? I'll make this pair. Why? Because this one is already being paired with some group, right? It is already being used. Always try to make the unused ones. If there was a 1 here, okay, if there was a 1 here, I would have made this as a quad. Why? Because this is having more number of ones, adjacents. Okay, since even I'm having a possibility to make a pair, I'm having two conditions where this one could be grouped with the one which is in cell number 0, or I can make a pair of this one in cell number 1 with the one in cell number 9. If I make this, it will become a redundant. Okay, so that's why I'm making like this. Fine. So I'll name it as group number 2. After solving the whole problem, let me tell you, if I do this as a pair also, in the final answer that will not be considered. Okay, in the last stage I'll show that also. Next, so our second group is done. Next, so this one is done. Okay, I'll go to the next line, next cell number, that is 3, but there is no 1. Okay, next I'll move on to the cell number 2. There is 1, but it is already being grouped, so don't worry about that. So our first row is completed. Next, go to second row. In the second row, this one is already being grouped. Okay, so don't worry about this. Is there any one? No. Is there any one in the next cell? Yes, we have one in the next cell, right? Okay, what I supposed to do now? For this one, what I have to look for? Look for an octet. Can I make an octet? Just think. No. Can I make an quad? No. Can I make a pair? Yes, I can make a pair, right? So what is that pair? I can make a pair by using the cell number 6 and the cell number 7. So I'll name this as the third group. Fine. Next, this is already being used. See here, I have used this one to make a pair here. Why? Because if I was not making a pair by using this, then in this case it would have become a single. Okay, the rule says whenever we are making a group, always try to have a maximum number of adjacency and make a group. Okay, so that's why I used that concept and then made a group. Okay, that is group number 3. Next I'll come to this. Okay, our second row is being completed. Next I'll come to the third row, that is rule number 1. Okay, in the third row, this is the first element. Okay, for this element or for this one which is in cell number 12, always look for an octet. Can I make an octet? Think. No, right? Next, can I make an quad? Yes or no? I can make a quad here. See, these two ones, that is the cell number 4 and the cell number 12, the cell number 6 and the cell number 14. If I wrap this paper or if I wrap this K-map, can I get a quad? Can I make it, right? Yes or no? So this will be my next group. This group number is 4. Okay, so this one is used. I grouped it. There is no one left out. There is no one. Here there was one before grouping this, but after grouping the cell number, group number 4, this one is already grouped. So no need to worry. And then here I don't have any ones. Here I have, but already being grouped. Okay, here I don't have, here I don't have. So I'm done with grouping the numbers or grouping the terms in my K-map. Next, what is the procedure? Next, I have to write the essential prime implicants table. Okay, how to write that essential prime implicants table? Let me tell you. First, to write that, we have to write the group numbers. Next, the prime implicants. Next, I'm writing it in short, essential cell number, and then next column must be essential prime implicant. Okay, so I'll have the 4 columns. In the 4 columns, I'm writing the, here I have got 4 groups, right? 1, 2, 3, 4. So I'm making a table which has the 4 groups. So this is my group number 1, 2, 3 and 4. Next, see, in the group number 1, where is my group number 1? This is my group number 1. We have already marked here, right? This is my group number 1. Okay, is it visible? Group number 1. For this group number 1, I have already shown you how to reduce the number of literals. Okay, see, for this first group, this block and this second row and first row is being used. Here x bar changed to x, so we will not write w bar remains same, so I'll write w bar. Correct. Next, for this block, this column, the first column and the fourth column being used, so I'll write y bar changed to y, so I'll not write z bar is remained as z bar, so I'll write as z bar. Okay, next, what do you mean by essential cell numbers? Here I have to write the cell numbers, that is 0, 1, 2, 3, 4, 5 like this, where the one is not being reused by another group. Meaning, see here, for this group, for the group number 1, it has the cell number 0, cell number 4, cell number 2 and cell number 6, right? Cell number 0, that is the one which is in cell number 0, is not being shared by anybody or any group, but the one which is in the cell number 4 is being used or grouped by the first group as well as by the fourth group, right? So essential cell number is a cell which is not being reused. It has been used by only this group, that is 0. I have to write this here. Fine. Next, we have to look for all the cell numbers of that group. So here 2 and 6 is there. The cell numbers for this first group is 0, 4, 2, 6. 0 is not being reused, so I have written. 4 is being reused, so I will not write. 2 is being not used, so I will write. 6 is being reused by 4 and used by 1, so I will not write that. Okay. So if we have any cell numbers here, then in that case this prime implicant will become essential prime implicant. So I'll write W bar Z bar. Fine. Next, similarly for the second group. For the second group, this is my second group. For this is the only column and these two rows are being utilized. W bar changed to W, X bar remains same. So it is X bar, Y bar, Z. Is there any essential cell numbers? See the cell number 1, it is not being reused by any other groups. So 1, 9. Since I am having an essential cell number here, I can write this as a essential prime implicant. Fine. Okay, next for the third group. This is my third group, right? This one, the small one, is my third group. For this third group, what is the term? Second row, and third column, fourth column. Okay, second row write as it is W bar X, and here Y remains same, Z bar, Z changed to Z bar, so I'll write Y as it is. Is there any essential cell numbers? 7. Essential cell number is 7. Why? Because this one is not being reused by other groups, so this will become an essential prime implicant. Okay. Next, similarly for the fourth group, okay, W bar changed to W, so I'll write only X. Here Y bar changed to Y, so I'll write only Z bar. The unused ones are there, check for it. Yes, it's there, cell number 12 and cell number 14. So this will become an essential prime implicant, X, Z bar. Okay, so this is our prime implicant table. Okay, in the while in the starting I had told you I'll make one more this group and this will not be a part of our answer. I had told you in the earlier stage itself, right? So let me make a group. I'll make it actually for this is your final answer. There is one more stage. If we make this as one group also, see here, if I make this as one group, let me call this as fifth group. Okay, fifth group. I'll write the fifth. For this, what is a prime implicant? For this, W bar Z, W bar X bar, and here Y bar changed to, sorry, Y bar remained same, Z bar changed to Z, so I'll write Y bar. See here, is there any essential cell number? Meaning, is there any single one which is not being used by any other groups? No, right? This one is being used by this first group, right? As well as by the fifth group, correct? And then for this cell number 1, this one is being used by the second group as well as by the fifth group. So there is no essential cell numbers. When there is no essential cell numbers, I can't consider this prime implicant as my essential prime implicant. So I can't write, or I can't consider this term as an essential prime implicant. If you group this also, it will be a waste of time and waste of your energy. Okay, so always go for octet and then look for quad and then pair. If not, then we can't do anything, leave it single. Fine. So the final solution is, the minimal sum is, the minimal sum is, what you have to write? You have to write all these terms by ORing together. That is W bar X bar plus, sorry, W bar Z bar plus X bar Y bar Z plus W bar XY plus X Z bar. Okay, this is the way to solve this problem. And let us discuss about how to write a Verilog program of the same. So this is the program to write, this is the Verilog program for the minimal sum what we have got, that is w bar z bar plus x bar y bar z plus w bar x y plus x z bar. Okay, how we have to write? Always our program must start with a module. The one first thing is everything must be in the small letters. Okay, module space, and then we have to write the name of the program. Okay, since the video was becoming very long, I wrote the program and then I am explaining. So here I have used the program name as 1C. Why? Because the problem number itself is 1C, that's why I have used any name you can use here. Okay, then here we have to mention the inputs as well as an output. These are my inputs, it's given in the question, and I have considered this as my output, or even in the question they have specified it is f of is equal to, so I have considered f as an output. Okay, so inputs I have specified, output okay specified, then I have used an assign keyword, assign f, that is output is equal to, then for this not, for the NOT gate negation symbol is used, negation of w, it is AND gate, w bar and z bar, right? So I have used an AND symbol, and then since it is z bar, it is negation of z. Okay, since it is the first term to be evaluated, I have used the brackets. In the order of precedence rule, I have already explained this about these symbols. Okay, you can go through that also, and then the OR symbol has to be operated, so the symbol for the OR gate. Next, for this expression, this is the expression what we have written in a code, and for this term this is the expression, and for this one. Okay, and then at the last we have to write the end module. For the end module we should not write any semicolon, and for each lines we have to write an semicolon here, write properly, and you should not leave any space between the word end and module. Okay, so this is all about the solution of the problem number 1C, which is being asked in the model question paper 1. I hope you understood this problem, and if you have any doubts you can ask me in the comment section, and also in the group you can ask. I will share the link of the Telegram channel in the description box. If you have any doubts, please contact. Thank you for watching and happy learning. All the best for your exams.